and looking at combining rational expressions. And let's say if we go with the operation of addition. And we'll start out with a couple of expressions that will have the same denominator. So we'll say we have 2x plus 7 over 3 plus x plus 1 over 3. And so here we have the same denominator, and I can add these fractions by combining the numerators. So we have 2x plus x, so this will make 3x. 7 plus 1 is going to be 8. And so for the sum of the fractions, we have 3x plus 8 all over 3. Now, and let's say if I look at combining rational expressions, and we'll say something along the lines, and we'll keep the denominators the same as well. And let's say that if I have something like 2x squared plus 5x minus 7 over 4, and I have the subtraction, and I'll be looking at subtracting the fraction, and we'll say that we have x squared minus 14x plus 7. Now, in looking at taking what we have here, now if you notice, we have the second fraction is going to be affected by the operation of subtraction here. Now we got the same denominator at 4. And if I look at combining numerators, again, so I have 2x squared plus 5x minus 7. And I'm going to have subtracting all of x squared minus 14x plus 7. So just looking at what we have at the moment. Okay, so everything in x squared minus 14x plus 7 will be affected by the subtraction that came from what we had in the original setup. Now, so we have looking at following through. So we had 2x squared plus 5x minus 7. And what was x squared is going to become negative x squared minus 14x. You have the negative of negative 14x, so this is going to be a positive 14x. And then we have minus 7. Now, as we look at combining the terms together, so we have 2x squared minus x squared, so this will be x squared. Then we have 5x plus 14x, so this will make 19x. Then we have negative 7 minus 7, so this will be negative 14. So for the difference between the fractions, okay, we have for the final result, okay, so we have x squared plus 19x minus 14 all over 4. Now, let's say that if we have rational expressions, okay, where we do not have the same denominator, and we'll say that as a third case. Now, let's say that if we have just something very basic, and we'll say that we have 2x over 5 plus 3y over 4. Now we got 2x over 5 plus 3y over 4. And if I want to combine as a single rational expression, what I want to do here is I want the denominator to be the same. And here we have now the least common denominator will be the smallest number that 5 and 4 will go into. So the least common denominator is going to be at 20. So if I treat these rational expressions and put these in the context of where the denominator is going to be at 20. So I have, first of all, so I have 2x over 5. And if I multiply by 1, in the form of the number of times that 5 will go into 20. 5 into 20 is going to be at 4. So I can multiply by 1 in the form of 4/4. Now as for 3y over 4, and we have here 4 will go into 20 5 times. So I can multiply this rational expression by 1 in the form of 5/5. So in taking what we have now, so I have 2x times 4, so I have 8x over 20. 3y times 5 becomes 15y. And 4 times 5 is going to be 20. And if you notice, okay, so we have both denominators are identical. So we have, upon combining, okay, we have for this single rational expression, we have 8x plus 15y all over 20. Now, if I take what I have in the context of multiplying fractions, and let's say if we have a couple of rational expressions, and we'll say we have 10x to the 4th y, and we have all over 3z squared, and I have times 2x squared z to the 5th, and I have all over 5xy to the 4th. And there are various ways that you can work with this. But I tell you what, if we just multiply out the numerators and denominators, so I have 10 times 2 is 20. X to the 4th times x squared is going to be at x to the 6th. Y times z to the 5th. Okay, so you don't have any repetition of y or z in the numerator positions. Okay, so we have 20x to the 6th. Then we have y times z to the 5th. Now, in the denominator, so we have 3 times 5. So we have 15. And in the denominator, none of the variables will repeat. Okay, so we have 15x y to the 4th z squared. Now, in the case of taking what we have and reducing, so we have for 20 and 15, greatest common factor is going to be at 5. And for what we have in x, okay, so you have x to the 6 minus 1. So x to the first will go out. Now for what we have in the case of y, higher order factor in y is going to be in the denominator. So we can take out the lower power. And as for what we have in z, the higher power rests in the numerator. So we can get rid of the z squared. And so for what we have upon reducing, so you have 5's will go out, you have x to the 0, y to the 0, z to the 0, each of these will end up going to 1. Now, and we have for the reduced form, so you have 4 over 3, x is going to be to the 5th in the numerator. As for y, we have y to the 3rd in the denominator. As for z, we have z cubed in the numerator. And so that would be the completely reduced form of what we have here. Now, for what we have in the context of multiplying, and say if I start out with the operation of division, say if I have 2xy over z squared, and I have divided by 4x over z. All right, now rewriting what I have in terms of multiplication. Now, again, if I'm looking at dividing by a fraction, it'll be the same as multiplying by the fraction's reciprocal. So 4x over z, reciprocal is going to be at z over 4x. And so lining up what we have here. So we have 2xyz, and I have all over 4x z squared. And if you notice in the case of the follow through, okay, so 2/4, okay, that would just go to 1/2. If you notice, you have x's will go out, y is going to remain. As for what we have in the case of z, you have the first order is going to go out. Okay, so we'll end up with y and 2 times z to the 2 minus 1, so that's going to be y over 2z. And so for what we have, again, so we have x is canceled out, 2/4 goes to 1/2, and we got y. Only factor in that variable is at the top, and as for z over z squared, again, you have z at the bottom. So for this reduction, we end up with y over 2z.